Hello everyone, I hope you can hear me. It is 1 o'clock here in Amsterdam and I would like to welcome you to the IPv6-Only in ISPs and Enterprise section of the IPv6-Only Educa. My name is Natalie Trenneman and I will be moderating this session, and I'm very proud that we have 3 people in this session. Oh, am I still muted? No, you hear me? Yeah, okay, good. I'm very proud that we have 3 people in the session with almost 70 years of IPv6 experience in total. And I would like to welcome Radek, Zajíc, Benedikt Stockebrand, and Jordi, Palet, Martinez. Please write your questions in the Q&A and I will read them out at the end of the presentation. Our first presentation is from Radek, who deploys IPv6 for fun. And he talks about the good and the bad side of IPv6 deployment in and IPv6 related compatibility issues. He has deployed IPv6 in Czech networks and will talk today about happy eyeballs, good servant, or bad master. Radek, it's yours.
Hey, I hope you can hear me, and now I believe you can see me as well. So let's start. This talk is about happy eyeballs and the relevant topics, and the subtopic is it a good servant or a bad master? So first, let's have a few words about myself. I'm from the Czech Republic. I work with the same community as Untitled Chapter, and I've spent the last more than 10 years by deploying IPv6 in multiple organizations. Some noticeable ones are Seznam.cz, which is the largest Czech content provider. And then there is a T-Mobile, which is the largest Czech ISP in terms of mobile customers, and the second largest ISP in terms of fixed customers, where I've deployed IPv6 on the DSL service, the way it should be deployed with at least /56, which is something that the largest carrier doesn't do. These days, you can find me at the Showmax service, which is a service that is provided in Africa, but has developers in the Czech Republic. So I work at the content delivery part of things, where I, except for enabling IPv6 on the content delivery infrastructure and the internal infrastructure, I mainly focus on getting the bits to the users. We have a tech blog, tech.showmax.com, and Twitter at showmax@devs. So let's start with a retrospective, which is important for this talk. In 2008, that's 12 years back, the IPv6 internet was mostly, or more than 50% of the IPv6 internet back then, and the internet traffic back then was carried over IPv6 tunnels. You may remember, if you were back in the business in 2008, that more than 50% of traffic was carried over IPv6 tunnels, that is 624 and Teredo. Less than half of the traffic back then was carried by native IPv6 connectivity. The 6bone, which was a experimental network running IPv6, native IPv6 over most cases tunnels, was phased out in 2006 on 6th of June. Well, that's 14 years ago. The network address translation, protocol translation, the predecessor of the current NAT64, was moved to historic status in July 2007, and A6 DNS records were still a thing for the freaks, because these records never really got into use, although they were a really interesting feature. And the dual-stack was the recommended transition approach in the leaf networks, in the local area networks, and server networks, server environments, and stuff. And 624 and Teredo were the only IPv6 connectivity for many early adopters back then, including me. And obviously, not a lot of content was available on IPv6 in 2008. So let's pause a bit with the latest statement that not a lot of content was available on IPv6 in 2008. Some of you may remember the IPv6.google.com, which was a IPv6 available Google service. And there were a lot of hacks how to get other Google services running over IPv6, but obviously unsupported. and it launched on 12th of March in 2008. And the reason why www.google.com didn't have a query record was because the query record would break users. That's a claim by Lorenzo Colletti, the IPv6 engineer at Google, from the RFC8585 meeting in May 2008. But why would it break users? Well, today there is a lot of content on IPv6, and the www.google.com was IPv6 enabled on 6th of June in 2008. So the question is, what has changed between 2008 and 2012? The answer is the IPv6 brokenness. Let's stop with the brokenness topic for a while. Let's imagine we have a computer with a dual-stack network and a server www.example.com, which has IPv6 address 2001:db8:det:1 and IPv4 address 192.0.2.1. If you attempted to connect to the server in 2008, you would be attempting to connect IPv6 connection first, because IPv6 was a preferred protocol back then. But what happens, and what happened back then, if the connection was black-holed? Well, the computer would retry, and there is a thing that is called exponential backoff, so it would retry after 1 second, 3 seconds, 6 seconds, 15 seconds. Maybe after 20 seconds, it would fall back to IPv4, and the connection would have been established, and the computer would be communicating with example.com over IPv4. Obviously, for the user, 20 seconds waiting time, and that's the optimistic case. In the worst case scenarios, it could take minutes or tens of minutes even. From user's view, the service is unreachable because no user wants to wait for 20 seconds. So most of these issues back then was caused by the automatic tunnels, the 624 and Teredo tunnels, share of which has decreased from 2008 to 2012 from more than 63% to less than 2%. And as of today, the numbers are like a fraction of a percent. These are some remains or desperate users that don't have any other tunneling capability, and they don't have any native IPv6 connection. So that's one type of brokenness, but there are obviously other types of brokenness. There are routing issues like misconfigured or missing gateways, ACLs, the access control lists, and so on. There are firewall and server misconfigurations where, for example, the query record exists in DNS, but the server doesn't reply to a connection that is initiated towards it for whatever reason. And then there are the path MTU issues, where the connection succeeds, but the transmission hangs because of the MTU issues on the path. Now, Happy Eyeballs steps in. With Happy Eyeballs, the first version, RFC8585, we have the same case of example.com, the same dual-stack client, which attempts to connect to IPv6 address of example.com first. But after a short while, the IPv4 connection is attempted as well, in parallel to IPv6. Then the IPv6 connection attempt is black-holed, but the IPv4 traffic attempt or connection attempt goes through. And the connection is established over IPv4. And then the IPv6 connection attempt is cancelled. So this is Happy Eyeballs in a nutshell. There is support among some web browsers mostly, with Chrome, Firefox, and Safari. There is support with Python RFC8585 library. There is support in curl, which is a command line tool to fetch content from the internet. But the head start value is different, and it can be even different between different versions. For example, with Safari, it can be 25 milliseconds in the latest version, but there's also other version that had different head start value. So let's think about happy eyeballs, the idea, the releases of RFCs and support amongst clients. The very first draft was published in July 2009, but it took nearly 3 years for the RFC to be published and about 20 versions, 20 revisions of that draft. 5 years later, a new version of API Eyeballs, the API Eyeballs version 2, which officially obsoletes the previous version, was published as RFC8385. So what is the support among clients? With the blue ones, Chrome, Firefox, curl, the Python library, and the Golang, you have the support for API Eyeballs version 1. With macOS X and iOS and iPadOS and tvOS and whatever comes from Cupertino, the API Eyeballs version 2 is supported. What does it mean? Version 1, version 2, is there a big difference? Well, let's think about the issues that API Eyeballs is supposed to work around. With the path and view issues, this is actually not handled by API Eyeballs because in case the connection establishes over IPv6, the client then attempts to talk over the IPv6 connection and doesn't fall back to IPv4. In case the TCP actually is timing out, the API Eyeballs version 1 and version 2 attempts to connect in parallel to the IPv4 endpoint and to IPv6 endpoint in a dual-stack environment. In case the TCP connection is black-holed or extremely slow, the case for API Eyeballs is to prefer the other IP protocol. This is all supported in version 1 and version 2 at the same time in dual-stack environment. But what if we attempt to deploy IPv6-only network with NAT64 and DNS64, and we attempt to connect to the IPv4 address literal, which obviously is unreachable on that network? Well, API Eyeballs version 2 has introduced the trick to synthesize the DNS, to fake the DNS64 address even for address literals. So it fakes the IPv6 address based on the IPv4 literal and the DNS64 prefix, and then it attempts to connect to the synthesized address. So, for example, if you are on a Mac OS X and you have Safari and you are on IPv6 only network with NAT64 and DNS64, you are able to or you are able to open the https://1.1.1.1, which is a web server run by Cloudflare, and you open it even though there is no IPv4 connectivity on that network. The other interesting feature of API Eyeballs version 2 is in case you have a dual-stack endpoint, for example, that example.com web server, and it's unreachable over IPv6 on a NAT64 enabled network, an IPv6 network, then the API Eyeballs version 2 synthesizes another IPv6 address from the DNS64 prefix and the IPv4 address of that example.com server, and then attempts to connect to the synthesized address again, which works around the issues of broken IPv6 connectivity. So the pitfalls. Most applications support neither version 1 or version 2, so there is no support at all. For example, with Internet Explorer and Microsoft Edge, there was no real support of API Eyeballs. In case your network was broken, you were just left out with the browser waiting to connect. Obviously, with browsers like Chrome, Firefox, and Golang-based applications where the support is native, or a proprietary app which includes API Eyeballs version 1 support or version 2 support, then there is a support. But in most cases, like with SSH, on Linux, on Windows, there is no support for API Eyeballs. In case your connection is broken, it's broken, and you can't connect to it unless you wait for a long time for all the IPv6 TCP attempts to fail. With browsers, except Safari on Mac OS X and iOS X, which uses system-wide API that implements API eyeballs version 2, browsers generally support version 1 only. So on IPv6-only networks with NAT64 and DNS64, you are left out with bad luck. You can't open a web page. I have a favorite web page that I visit, and I've reported to them that the IPv6 connectivity to the web server is broken in January, and it hasn't been fixed since, so I can't use Chrome to open that page. On IPv6-only access networks using DNS64 and NAT64, the benefits of Happy Eyeballs version 1 are erased, so there is no benefit at all. It doesn't bring you any improvement of user benefits, browsing benefits. And the Happy Eyeballs version 2 is only supported on Cupertino platforms, so it's macOS, iOS, and so on, which is sad. So what is the level of brokenness in 2020? Are the issues solved already? Well, Teredo and 624 are a niche now, except for the very desperate users using them. You won't find them available and active in operating systems, so you have to do a lot of manual steps to enable them and use those two tunneling techniques. So this is a good thing. But every now and then, new access networks enable IPv6. And every now and then, new content providers enable IPv6. Mistakes are natural and do happen, and we all have to live with it. But the Happy Eyeballs version 2 is not omnipresent, sadly. So users on IPv4 only and NAT64 enabled networks do see the brokenness unless they have Happy Eyeballs version 2. So what about the brokenness levels? Are there any measures, or did someone attempt to measure those brokenness levels? The answer is yes, but mostly only for the access networks. APNIC has a statistics on stats.labs.apnic.net where you can see the country level of brokenness. In this case, it's Time Warner Cable in the United States, where the country average is 0.6%. 0.6% of IPv6 connections in the United States break. With TWC, it's 3 times more. So something's really broken in that access network, and it's constant over time, apparently. But please ignore the spikes. It's likely a measurement error. With T-Mobile in the United States, the brokenness is quite low, and the reason probably is that T-Mobile US uses IPv6 only access networks in the mobile network and has a DNS64 and NAT64 enabled deployment. So whenever something's broken, they see it quickly and they fix it quickly. So in some countries, the failure rate is extremely high, and it's not just the countries with low IPv6 deployments, but also in countries like China, where we see hundreds of millions of IPv6 users, the Saudi Arabia, where the deployment has accelerated recently, and Vietnam, which is not on this slide yet. It didn't fit there. You can check your country, you can check your ISP, and if you are an ISP, you can check what the brokenness levels are in your network. Another example of brokenness is from last year, where Airtel, I think it's an Indian ISP, has announced an IPv6 block 2400:/12 for a week, and no one noticed that it was the typo from /127 because it's IPv6, and well, it's IPv6 and nobody's using it, right? So I have another example of the brokenness with Vodafone Czech Republic, which connected to NICS-CZ, but they failed to configure the ACLs, so they were dropping all the traffic over IPv6, which was arriving over NICS-CZ. And they didn't notice, mostly because they've only IPv6 enabled the website. Another good example, or a bad example, is Liberty Global, operating as VodafoneZiggo or UPC or Vodafone now. They started to giving out users IPv6 addresses to the on the access networks, but they have failed to update the ACLs on the edge, so the user's traffic was black holed. And they didn't notice until I've really pushed hard for them to fix it. And then they did it again. Considering they are deploying IPv6 on a large scale in all European networks, that's sad. Another example is their CDN for the TV service called Horizon Go, which is a mobile app. The CDN was not properly IPv6 enabled. It had Quad A records in the DNS. It was reachable from the outside of Liberty Global's network, but it was not reachable from inside. So if you're a customer, the application was attempting to load it, but because it didn't implement API eyeballs, it failed. And it failed on Chromecast as well, because there is no API eyeballs in the media player there. With T-Mobile, I have reported an issue with significant brokenness, where like 50% of the traffic was dropped because of routing issue. And the last example is from my latest small ISP, where they were doing changes in IPv6 configuration, and they have for some reason failed to update one ACL, and it black holed all the traffic. So that was weird, and even the weirdest part was that I was the first one to let them know. The conclusion: should we abandon API eyeballs because the benefit on IPv6 only with NAT64 and DNS64 networks is limited? Well, rather not. It's a good servant of ours. It's masking the brokenness, and while we work on the brokenness, we should definitely keep use the technology. Should we depend on it to solve the brokenness problem? In case something's broken, should we say, okay, it's fine, API eyeballs will take care of it? Well, no, because API eyeballs, it's not everywhere, and API eyeballs version 1 fails in DNS64 and NAT64 networks. Should we deploy more DNS64 and NAT64 enabled end user networks? Because if there is brokenness, should the users see the brokenness? Well, I think that if we ever want to turn IPv4 off, then yes is the answer. We should deploy more DNS NAT64 enabled networks. Is IPv6 a second-class citizen? Certainly yes. Monitoring is heavily underestimated and neglected, and there are too many issues. I would say I'm kind of scared how many issues are there with IPv6 networks. So one last message: please do not wait for your users to be the first to identify your misconfigurations if you operate a IPv6 enabled service or network. And that's it. And now it's time for Q&A. Thank you very much.
Muted. Hey Radek, thank you. That was an excellent presentation. I have a question for you, and it wasn't in the Q&A, it's from myself. So not all the browsers have done Happy Eyeballs version 2. And yay, thanks for sharing.
Sorry, I thought it was enabled and it wasn't probably. Apologies.
No worries. Good to see you. Anyway, my question for you. Do you have any insights, maybe, or ideas when Happy Eyeballs version 2 will be deployed in anything else than iOS and Mac OS X? Yeah, Radek is frozen at the moment, so we can't hear it. We can't see him. Well, we can finally see him, but now we can't hear him. So, Radek, if you can still hear me, my question was if you have any insights, if you know when Happy Eyeballs version 2 will be deployed anywhere. If you can hear me, you can write it in the chat. Yeah, unhappy eyeballs because of the video. So then we will take it to the next presenter. And my next presenter is Benedikt Stockebrand. And Benedikt has specialized in IPv6 and its deployment since 2003, and that's 17 years already. He is the author of an early book about running IPv6, and he has carried out IPv6 trainings for more than 10 years. And is currently specializing working as a freelance consultant for deploying IPv6 in non-standard environments. and today he will present migration strategies from IPv4 only to IPv6 only. So Benedikt, please share your webcam, share your, we have your slides, I believe, so we'll take care of that. Everybody else, please ask your questions in the Q&A, because that will be easier for me to read out after the session. Thank you and enjoy.
Okay, so there are no slides yet. I'll start anyway. Only the last few slides are actually. Sorry? Okay, so as Natalie mentioned, my biography, so I don't have to go through that again. Except maybe that might be a bit interesting because it shows how non-standard IPv6 can be. I'm currently working on a project deploying IPv6 to the German Railroad, Deutsche Bahn, ICE high-speed train fleet, which is completely unlike a data center. And I'm doing that sort of stuff as well. Now, there's slides. Hey, cool. Let's see if we can get them proper size, sort of. Oh, that's too big. Okay, so that was about me. So when we talk about doing IPv6 only, first thing is, what are we actually talking about? I mean, IPv6 only obviously means you remove IPv6 from your operating system kernel. So there is not even IPv4 localhost errors on your loopback interface. And if you're doing the software development, do it. You'll be surprised how many things break. If you do operations, don't even think about it. So when we talk about IPv6 only, the first thing we need to do is understand what we actually want to achieve. And once we get an idea about that, understand what options we have, what sort of mechanisms to connect to whatever IPv4 we actually want to talk about. And then eventually you get to the point where you have to decide, okay, you hopefully know you're somewhere here and you want to get there. That's your initial target architecture, basically the idea where you want to go. That's fairly easy. Point is then you have to start moving towards that target architecture, and that's where the work in this transition part, that's where you really have to put some work into. And the fundamental idea is do many small steps, retractable steps, so you can backtrack if you decide something doesn't work, and keep updating your final destination, basically like your lighthouse somewhere, so that gives you an idea which direction to walk to while you're in dense fog or whatever. And you really want to update this. You can't deploy IPv6 without some sort of agile approach, if you like, where you redefine your targets along the way. And the most important thing about when you do this, or one that really saves you from a hell of a lot of trouble at least, is throughout this entire process, try to minimize the amount of dual stacking that you have to do one way or another. There are two reasons for that. First one is because dual stack adds to the workload, especially of the operational people. If you have to do IPv4 and IPv6 in your firewalls, in your networks, on your DNS and whatnot, it actually adds to the work, and you want to minimize that. Unless you work in an environment where there are lots of people and everybody's fighting about getting their share of work because there's so little work to do, which doesn't happen in IT anyway. Second reason is, and this is really important, if you just take your existing IPv4 architecture, which is seriously constrained by the limitations of IPv4, and just put IPv6 in there, you lose the chance to clean that up and redesign your entire environment where you don't have to worry about all these legacy constraints that don't apply to IPv6 anymore. That can be rather important. Now, when you define your target architectures, there are a couple of fundamental strategies, of course, where you can eliminate IPv4. And Toro talked about that in the data center environment before. I'm going to talk about that in a slightly different context. Similar idea, basically. If you can't eliminate it, at least minimize it and isolate it. Keep it somewhere out of harm's way for the rest of your organization. Something else that can be quite important is put a price to it. Basically figure out or get some idea how much extra work does it cost to you or your operations people if you don't do operations yourself. And it also helps to put some money-wise price tag to it to talk to management. Sometimes you have to do that even in our business. And if nothing else, prepare to expire IPv4 over time. Eventually, it will go away. And if you are not prepared to get rid of it at some point in time, you have an unnecessary problem. Now, a couple aspects of your target architecture that you can or should think about. When you talk about router-only networks, your core network, your backbone, only different people use these terms for different things. Basically, if you don't need IPv4, disable it so it can't sneak back on you because some applications start to use it again. Just turn it off. If you can, and you can frequently do that in your data center or whatever LAN, separate IPv4 from IPv6. Just use different VLANs if you still use VLANs. That sort of approach gets you a long way. You'll have twice as many VLANs, but they'll be only IPv4 or IPv6 rather than half as many where you have to watch out for both interfering with each other or figuring out which side is causing you problems. Similar thing when we talk about server networks in the data center, you can separate v4 and v6. Even if we talk physical servers with a limited number of network interfaces, just use VLANs. Server operating systems these days understand VLANs, and you can have a single physical network interface set up as a trunk and provide separate VLANs for v4 and v6. Tends to help cleaning things up and making things easier to handle all the way. When it comes to client networks, which is what Tore didn't talk about because that's not his part of the business, but mine, sometimes client networks are really where dual stacking really hurts. They're large and there's a huge number of applications all sorts of clients use, and frequently you can't even tell which applications are used because people are using things all over the place that you don't even provide yourselves. They normally have a single network interface or maybe one LAN and one Wi-Fi interface, but that doesn't help you anything either. So you can't separate v4 and v6 on different network interfaces, physical interfaces, and you frequently, well, you can try to use multiple VLANs, but with most desktop computers these days being notebooks and supposed to work if you take them to the next coffee shop for a break, that's not exactly straightforward to set up. What you can, however, do, and that's where actually COVID kind of helps, is you can take whatever VPN software you have on these machines these days, at least since COVID, and with the necessary server infrastructure having been set up rather frantically during the last 3 months, you can just use your VPN software to provide IPv4 as a service. So you can make your machines IPv6 or your client networks v6 only, and you can provide IPv4 over that using your VPN software pretty much for free. If that doesn't, generally speaking, you only want to provide dual stack as needed, not just for the fun of it and do some blanket IPv4, IPv6 dual stack approach. And the good thing about client networks frequently is that you can deploy IPv6 or discontinue IPv4 in many small steps, basically down to the point that you run a new v6 only VLAN all the way to the switches in your access networks in the office sense where you connect your client machines, not the provider sense. And then you can migrate individual switch ports from one VLAN to another. And that usually means individual machines. You don't get much finer control than that. And it's still going to be a lot of work, depending on the number of clients, but at least you can take a small incremental approach and build some experience and figure out where your particular specific problems in your environment are. And that tends to work out quite nicely. Biggest problem frequently is not the client networks, but the applications. And that's a hell of a lot of work is in there. It's not the run-of-the-mill standard applications that you have, but it's like, you know, Office and Outlook and whatever. But the more specialized stuff where it's frequently painful to get IPv6 supported. You can try to upgrade them if they don't support IPv6 already. You can try to replace them if even the latest version doesn't support IPv6. You can frequently provide them through terminal servers. So you isolate the application to a few servers doing IPv6, doing IPv4 for the application, but you connect from the client to the terminal server using IPv6 only. And if you reduce the amount of dual stacking by 90%, that's a hell of a saving to get things done. And only if you really find even this is not an option, because it's a special software doing real-time, high-resolution video, whatever stuff, then you deploy IPv4 to those machines and those people who actually really, and I mean really, need it. Now, that's about architecture. And as you see, with the way things develop, you want to change your destination or targets along the way. The migration path, it's frequently where the work is in. And the first thing you pretty much want to do is get your people and your organization ready. You don't want to teach everybody about IPv6 just yet, but you need a few people who actually understand what they are doing and what needs to be done to get things started. And then you can spread the word along the way. You need the DNS. DNS is probably the first thing that you're going to dual stack and the last thing where you switch off IPv4 on. It's not really difficult, but you make a mistake with DNS and you'll have a rather unpleasant talk to your boss because you basically shut down your entire organization. Firewalls, pretty much the same thing. You do need monitoring. As Radek said before, this is frequently neglected all over the place, and you want monitoring, partly because you want to have monitoring as such, but partly because it really helps if you can check automatically, is everything still working, can I go on, or do I have to fix some problem that I just created while trying to migrate to IPv6. And you need the network in between these. And the networks are generally not the biggest problem. The biggest problem is that with the applications, actually. So what you then do, once you've got the basics up and running, and I mean really the basics, so you can start with the other stuff, is you pick some application or service. And you go for something small, something that's not going to have pretty much huge business attention, and you try to migrate that. And I kind of disagree with Thor here, not because I disagree with him as such, but because my understanding of a normal environment is different than his. I'd rather not start with the load balancers or wherever I do the dual stacking towards the customers, because that's where frequently, if you make a mistake, other people will notice and you'll get complaints. So you rather want to do that in some area where people won't notice right away and you can clean up the mess you create if things go wrong. So you go for something small, not too business critical, build up some experience while you do this, and you set up a backlog of things that you still need to clean up but can't clean up right at that point. First thing to go in there, last thing to go out there is DNS, which is necessary to do IPv4 and IPv6. That's pretty much on the server side. On the client side, it works about the same, but this really depends on your particular environment. So you go for the easy targets first, whatever they are. If you want to look for machines that aren't too important, go for the ones that your interns are using, not your management board. If you have client machines that only do a very specific job and don't run the whole range of software available in your organization, go for those. You have to decide that yourself. There's no one-size-fits-all solution to that. And understand the options you have when it comes to workarounds, like terminal servers, like NAT640 and S64, which I personally don't like too much because they're applications that break if you try to use them, and that causes some kind of trouble occasionally. But you really have to decide on that yourself. And now, finally, examples. And now this is a bit annoying because I can't get this to full screen. Oh, this is about full screen. That should work. So I'm going to talk about server-side example. It's kind of like what Toro talked about, but more in enterprise context. So no, that doesn't quite work. It would have been too easy. So first thing you do is identify the application example, the application components, sorry. And this is about as generic as it gets. You have some database. Hey, hang on, we need the pointer. So we have database, let's do it like this. Database servers, we have application servers, we have web servers, and we have load balancers. And that's pretty much as generic as it gets. Yes, there are some non-web-based things, but this should be familiar to everyone. And you can follow pretty much the same pattern on virtually all applications, at least if they are multi-level like this. Now, next thing you want to do is identify where you want to do the dual stacking. What's happening on the presentation here? It looks funny on this screen. So you want to decide where you want to do IPv4 and IPv6. In this sort of setup, you frequently do that on load balancers. Some cases you might set up a terminal server to provide some sort of service. Pretty much whatever kind of makes sense for you. Now, let me try it. Now that wasn't a good idea. Once you have that sorted out, and you want to only do this at one place, you want to have one border place between dual stacking on one end and single stacking on the rest. Then you can continue to figure out what infrastructure you need. You always need DNS. You pretty much always need monitoring, unless you use your users to do the monitoring for you and call you if something breaks. You might find, okay, in this case, I need NTP for some specific reasons or whatever else. You take a look at that. And you can complete your infrastructure by following these individual applications. Then you figure out what connections you need to do with IPv6. You don't have to do all of them, but you will need some, especially from monitoring and quite likely from DNS. Well, you might still use some IPv4 between these, but monitoring, you need to monitor things in IPv6. Once you have that, that's when fun starts, because then you have these application level connections between, let's say, web server, between web servers and application servers. And you take a look at this very specific connection and get that to work with IPv6 and IPv6 only. No dual stacking here. Doesn't make sense. And if you follow that path, you can break your migration down to very, very small and clearly defined and easily manageable steps. And it's still going to be a lot of work, fair enough, but it will work without extended trouble. If you did this all, in one go and things break, you don't know where to look for a problem. go for individual such connections, at least when you start with this, it's much easier to deal with problems, build up experience. Eventually you just decide, okay, this is just another one of these standard things, and I've got that in Chef or Puppet or Salt or Ansible or whatever. This is how I do it. And then even the bigger applications don't turn into any serious problem. Okay, that was just a couple of ideas. Important thing is every organization, every business is different. So this is not something you just follow because that's what somebody at this RIPE event said. You have to think yourself, but this should give you some idea what you can do and what you should do to get IPv6 up and running without any unnecessary problems. Right. In case you have any questions, you can reach me. I tend to be available every once in a while. The video blogs here, there are a number of episodes on IPv6, so you might want to take a look at that sometime. And other than that, let's hear your questions, either here or send me an email.
Hey, Benedikt. Excellent. Thank you so much for your presentation. I have one question and something I forgot to mention in my introduction, and that is quite important. You have been the IPv6 working group chair for the RIPE region for quite a while. So I want to pitch the IPv6 working group here as well, because there was quite a lot of interest from the IPv6 working group for this event as well. So thank you for pitching that. At the moment, we have around 360, 370 people watching. So that's good to know. And I know that quite a lot come from the IPv6 working group. So I just want to mention that. And then I have another question for you. You mentioned the IPv6 VPNs. Sorry, you mentioned VPNs in your presentation. Now, VPNs have been known to be notoriously bad in supporting IPv6. I have not been following everything in the last 2 years, but have you seen any progress when it comes to VPNs and IPv6?
If you use commercial products, you want to check first. That's definitely true. When I wrote that book like 14 years ago, I actually used OpenVPN at that time, especially as a tunnel mechanism, and it worked back then. I guess it still works today. Otherwise, we'd have to talk to get going about it. So there are options there, but it's true. I've seen some crazy stuff happening with firewalls in the last couple of years, where you expect people to get things done by now, and VPNs can be a bit of a problem. Sometimes you want to investigate those things, but there are reasonable VPN solutions out there that work, like OpenVPN. I haven't got around to try WireGuard yet, and I'm kind of an open source guy, so especially when it comes to security, I'd rather go with something where I can take a look at the sources and decide, no, I'm not going to use that, rather than look at the price tag only. So yes.
Yeah, thank you very much. I didn't see any questions being posted in the Q&A, but as Benedikt told you, he's quite available. His contact details are there. Please do reach out.
Yes.
And with that, thank you very much, Benedikt. Wonderful. Our next presenter, I'm also very proud to have him here, is Jordi Palet Martinez. And Jordi has been involved in IPv6 policy making in the IETF, the Internet Engineering Task Force, and the regional internet registries for many years, since even before I was working at RIPE NCC in 2007. He has trained over 65,000 engineers in more than 150 countries, and he was recently mainly working on IPv6-only strategies and deployments with IPv4 as a service. He's an expert in Net64, and today, how appropriately, he will present on using Net64 464XLAT in ISP and enterprise networks. Go ahead, Jordi.
Thank you, Natalie. Can you hear me? Can you confirm?
Hear you.
Yeah, okay. First of all, this is a very short presentation because this topic probably will take several hours. So bear with me if I am rushing a little bit or I am not offering all the information that you may need, but at least you have a glimpse of what is needed, okay? Now, okay, sorry, wrong key, this one. Now, two important documents because all what I am presenting here comes from real experience in deployment in both enterprise and ISP networks. In fact, right now I am doing a deployment for 25 million subscribers in one ISP. I cannot yet announce which ISP, neither the country. This deployment is including DSL, GPON, and cellular, and all is being done with 464X-LAT. We have done first testing to show that NAT64 was not sufficient. So that driven the decision of the ISP to go to 464X-LAT. And all the experience that I have got during several years on this kind of deployments, I put it together in two documents in ITF. One is RFC8585, which is basically telling you what your CPEs need to have to support any of the IPv6-Only and IPv4 as a service technologies. And the other one is RFC8683, which is basically about all the details you need to consider in both cases, ISPs and enterprise networks, to deploy 464X-LAT, and also why in most of the cases NAT64 is not sufficient. Of course, this information is general. You need to tailor it to your own specific case because every network is totally different. And one thing that I want to comment here is that in general, and I think it has been mentioned before already by some of the previous speakers, one of the bigger problems is that the knowledge of IPv6 in most of the cases is not good enough, and there are many misunderstandings. And one of the misunderstandings is what is IPv6 only. So I have one more ITF document in the works that is trying to explain that. Okay, so if you want to take a look, basically the point is to make sure that you state which part of the network you are referring to as an IPv6 only, because you may have some subnets or some parts of the network which still need to be dual stack, especially the end user LANs. Typically you need to do that because otherwise some applications may break because they don't work yet with IPv6 only. They may work with dual stack, but maybe not with IPv6 only. Okay, more details about the RFC8683 basically is telling how to deploy either NAT64 or 464X-LAT as set in both enterprise and ISP networks, and this is valid as well for broadband networks or cellular networks or combination of both. Some of the key questions of this document is basically, is sufficient NAT64, of course, with DNS64 for your case? And something that you need to understand here is that NAT64, if you are not using 464X-LAT, mandatorily needs DNS64. Okay, so that combination is a must, but in the case of using 464X-LAT, DNS64 is not mandatory, it's an option. So in the document I am studying all the issues that you need to consider for your deployment, and I am trying to classify all the possible scenarios according to some points which basically I can summarize like there are hosts in the network that will be validating DNSSEC, because this is very relevant when you are using DNS64. There are applications which are not compliant with IPv6 APIs, or they are still using IPv4 literals, or there are maybe still some IPv4 only host or applications. So that gives us classification scenarios. I am going to go through those scenarios just with a quick picture. I am not going to stop by each of one. So the first one is having NAT64 with DNS64. The second one is having the NAT64 in an external service provider. The third one is having both the NAT64 and the DNS64 in the external service provider. And then the fourth one is having only the DNS64 in the external service provider. Okay. Then we have the scenarios with 464xlat, and here there are two types. One of them is using DNS64, and then we have here again three scenarios, similar situation as in the previous slide, so I am not going to repeat all of them. And finally, we have two more scenarios, which are when we use 464xlat without DNS64. Okay. There is an additional set of scenarios that I am not commenting here because they are very, very specific cases, so I don't think it's worth to present them here as well. Now, the next thing I do is I compare all the scenarios. In total, you see in this table that we have 12 different possible scenarios. Okay, so I am trying to see different aspects which are key to succeed with this deployment. Like already mentioned, the DNSSEC, the literals and the APIs, the IPv4-Only. What happens if the customers are changing the DNS, and that's what I am calling foreign DNS, either because they change it manually or because they are using privacy, like for example DOH, or because they are using VPNs. Okay, so all these things present the same problematic when you come to an NAT64 or 464xlat deployment. And then optimization details like DNS load optimization or connection optimization. So I am classifying every one of the 12 possible scenarios as if it's good for that criteria, if it's bad, or if even if it's bad, it can be resolved, for example, by means of Happy Evolves version 2. Okay? So this is the summary of the comparison. And again, we don't have sufficient time in this presentation to go through all the details. I really encourage you to, even if it's a long document, I think it's about 35 or 40 pages. I think if you are really planning NAT64 or 464xlat deployment, you should really read the full document and take a lot of the considerations that the document is using to be adapted to your own specific network case. And then I have also a section in the document which talks about how I apply this to enterprise networks. Okay, and the idea here is maybe the ISP is still offering you dual stack, but you want to get rid of as much as possible of dual stack, at least in part of your network. Maybe you can keep just IPv6 in the servers, or maybe you have some specific network segments which are IPv6 only, and maybe you still have to keep some segments which are dual stack, like for example, if you have all IP cameras that don't work with IPv6, right? Or you have your accounting department which have some applications where IPv4 is still needed because they don't work with IPv6. There are many possible situations about why you need that. And here again, I am talking about three possible scenarios. In general, all the considerations are really similar to the ISP network, right? So there is, in fact, obviously the enterprise network is much simple in general. Now, going back to an ISP network, the considerations in a broadband network are the common ones when you deploy any new technology. How is the support for IPv6 only? Because the key here is making sure that they still work with IPv6 only, not just with dual stack. And you need to look into different parts of the system like provisioning, radius, the broadband remote access servers, the OLTs, the DSLAMs, your billing, your monitoring, all these kind of things. One important problem that I often find in many networks is that they do a very good monitoring for IPv4, but when they deploy IPv6, the monitoring for IPv6 is not, let's say, they don't pay so much attention. And sometimes this is being resolved by happy eyeballs, but some other times happy eyeballs cannot resolve that. So your network is broken and you don't realize it, or you don't discover the problems because happy eyeballs is hiding that for you. Now, of course, the very important part in any broadband deployment is what about the CPEs? So that's why we work in RFC8585. And the idea here is, do you want to support several IPv6 only and IPv4 as a service transition mechanisms, or you just go for 464XLAT? Because then the requirements are simple, obviously. In fact, 464XLAT is probably the simple transition mechanism for IPv6 only and IPv4 as a service for deploying in any network, right? How they configure the NAT64 prefix. There are many CPEs that come by default with the well-known NAT64 prefix, but there are also different mechanisms to automatically configure that if you want to use a different one. I in general don't recommend using a different than the default one, but in some cases it may be needed. So what you do with your existing CPEs? Are you going to reflash them? Do you have your CPE providers actually giving you new firmware that support 464XLAT, or in general any IPv6 only and IPv4 as a service transition mechanism, or you replace them? Maybe it looks like replacing them is very expensive, but if you replace all the CPEs, you are going to save money in having less NAT64 boxes, and you are able to offer your customers, your subscribers, maybe marketing operations or actions to tell them, hey, I give you the new Wi-Fi 6 and you just pay $15 and I pay the rest. And actually probably you can get those CPEs by $15 depending on who's your provider, right? So there are tricks to make that not really big cost for you, right? Now, what about the cellular network? The questions are here similar as in broadband network. Is all the equipment ready for IPv6 only? Because I have seen situations where they work just fine with dual stack, but not really with IPv6 only. So you need to make sure with your vendors that it supports it, and you need to have the control on all the elements to coordinate that deployment. I have been in situations with many service providers where they don't have the control over the packet switch network. They need to rely on the vendor for doing all the changes. So that means it's a slower process, and you really need to give them all the requirements. A common question is, do you need to have multiple APNs or just one? And my recommendation is just one APN is sufficient, and you will, with a single APN, you will be able to work with all kind of user equipment devices. Okay, so that's an automatic thing. And you can also do a gradual transition to IPv6 only, and then over-the-air updates to keep updating the different, let's say, areas or customers or customer groups or whatever you want to do that update. Regarding the smartphones or the tablets or whatever is the user equipment, Android is supporting already IPv6 only and CLAT by default. iOS requires the operator to liaison with their Apple contact to enable it. You can do some tricks to do that in a test bed. I have done that several times, so you don't really need to rely on Apple for a test bed. And then we have Windows that has a specific CLAT support, but only for the cellular interface. Okay. So that's basically how you do that in the mobile or cellular network. What could be the impact? Well, I think it's important to really see what will be the impact in the network by doing a test bed, by analyzing the network, by studying what you need to change, what are the consequences. That's generic for any deployment of any new technology, we already know. Things that I have done typically is looking at DPI for relevant data, like, for example, what applications are the most common used in the network, and then testing those applications to make sure that 464xLAT will work with them. I never found an application that is failing, but it's worth to try. How much traffic will be for each application, that will give you some hints about how you dimension your NAT64 boxes, how much traffic is going into the CDNs or caches, what is the usage of DNSSEC, and of course, if you need logging according to the specific regulation on the country, right? Can we allow any level of failure? If there is a specific application, again, I have not found it before, but just in case there is a specific application that is not working well, could we just say it's not a problem? We will give the customers that complain dual stack instead of IPv6 only, or can we develop ALGs to support that application? And of course, high availability. You need to calculate also how much is the bandwidth in your network. Typically, my experience, and this has been publicly reported by other operators that are really doing big deployments of IPv6 only, is that only 24%, and this is numbers from about 2 years study, now is probably much lower, only 24% of your traffic will go through the NAT64, okay? And this is key because if you have more residential customers than enterprise, this will be much lower, and it can be so low as just 5, 10, 15% of NAT64 traffic. So that's a very important aspect as well. And I think it's my last slide. I hope I am doing well with the time. In summary, in my opinion, NAT64 with DNS64 is not a solution. I have not yet found any environment which this really solves all the problems. 464xLAT, however, is working in all the cases. And even if you don't want to use DNS64, that it's an advantage for 464xLAT. Okay? And yes, deploying IPv6 only, you get savings. It's a question of CapEx, it's a question of OpEx. For example, you are not needing to buy more IPv4 addresses. In fact, you will be able to sell or to transfer part of your IPv4 addresses. I am actually working in another ITF document where I plan to describe how many IPv4 addresses you need depending on the number of subscribers. But it's really less addresses that most of the people will suspect. And if you replace the CPEs, which it seems expensive, actually you are reducing, I already mentioned it before, the cost in NAT64 investment. So it's much better choice than having more NAT64 boxes and keeping all CPEs and having all problems, and still having some customers that don't support their CPEs IPv6 only, and then having a mix of customers which are dual stack and others which are IPv6 only, etc. So really, I suggest that you need to investigate the financial on this, because it's much complex than what it looks like, and your first impression is, wow, I need to replace the CPEs, this is a non-go, but actually you are wrong. And that's it. Thank you very much. Questions?
Hey, Jordi.
I hope I did well with the time.
Yes, excellent.
Natalie?
Perfect timing. You had 30 seconds left.
Okay, thank you.
Mark. Excellent. I have 2 questions for you, Jordi. First question is from Kevin, and I like this question. I got this question a lot, and I'm sure you had as well. In the past, it has always been the story of implementing dual stack for the IPv6 migration. Now you are all quite much talking about IPv6 only. Is dual stack so bad or unrecommended, or is this just for the push of IPv6?
You know, the ideal situation will be dual stack, but there is no ideal situation with dual stack when we don't have any more IPv4 addresses. So I was the first one saying, when I was doing trainings of IPv6, even just 5 years ago, don't go to translation. Don't use these kind of things. They are bad, they are ugly. But I needed to change my mind because it's a reality check. I cannot keep recommending customers to go to dual stack. Of course, monitoring is more expensive. You have some additional cost when you have dual stack, but the main problem, especially for ISPs, not so much for enterprise networks that use private IPv4 addresses, but for ISPs, the big problem is they really need to sync in the long term without IPv4 addresses. That's it.
Yes, I agree with that. The next question is from Ilyich. If we deploy 464XLAT, how do we eventually end up in an IPv6 only world?
Yes, actually that will happen in a natural way. Why? Because when you use 464XLAT, only the traffic that is not going end-to-end IPv6 will go to the NAT64, okay? And some of this traffic will go also through the CLAT, but this is something that is done automatically. You don't need to turn off the switch. So as more and more services and more traffic is going to CDNs, which are already dual stacked, it means your usage of NAT64 will be lower and lower and lower. So that's a natural transition or migration in this case to an IPv6 only world. I like to differentiate transition than migration when I am doing trainings, because for me, transition is attached to coexistence. Okay, so transition basically is dual stack and some other transition technologies, but you keep dual stack. But actually, when the end goal is IPv6 only, if you are not using any more transition technologies, it's just a migration. So at the end, it will be a migration. Right now, we are still in the transition phase.
Yeah. Clear. Next question is from Martin Bernier. I was under the impression that 464XLAT is an endpoint OS thing. I learned today that it is possible to get it working on a CPE. Allowing multiple endpoints, non-464XLAT compliant to be supported. Is the 464XLAT really deployed in CPEs instead of endpoint OS?
It depends on the scenario. If we are talking about a cellular network, where basically every device is alone, maybe with other devices, but the device is behaving as a router because it's doing tethering for other devices, then the CLAT is supported in the end device, okay? But in the case of enterprises or ISPs, obviously the support is much better, not in each individual device, but in the router or the CPE, or in an enterprise network, for example. In many occasions, I am using just a virtual machine with BPP or Joule. That's it. So that means that you have your default network infrastructure. You don't need to add a new box, but if you have a virtualization environment, you just run a very simple to configure open source with Joule doing the functionality of the CLAT. And it's a very lightweight mechanism, so it's transparent, and again, you don't need to change anything in the network.
Okay. I have two more questions.
There was a different part of that question.
Yeah.
I forgot. The support in CPEs. Well, that's the idea of RFC8585. To tell the CPE vendors you need to support it. Right now, of course, open source software for CPEs like OpenWRT supports it. And I am working already with about half a dozen of commercial vendors for CPEs. And I cannot show you it here because it's under NDA. But of course, for this 25 million subscribers deployment, I need CPE providers which have 464XLAT support in the firmware. So that's done already.
I have 2 more questions for you, but we run out of time. So the team will get those questions to you by email. So if you can reply to that, that would be awesome.
Yeah, perfect, of course. I will
Okay,
do right
excellent.
now.
Those questions are from Radek and from Sibrecht Minyao. Jordi, thank you so much for your presentation.
Okay.
Yes,
Thank you very much.
thank you.
Bye.
Bye. That concludes the end of this session. I'm going to make space for the next session, which will be the last one for today. In the chat, I just pasted a link to a SurveyMonkey. If you could read that and fill that in on behalf of the learning and development team, I would like to thank you very much. And thank you so much for watching this section. Good luck with the panel. Thank you.
Okay. I assume I'm on. Hello. I think we're going to roll straight into this session. So hello to you all. I'm Marco.